In this video, we are going to try to find the derivative of a function, or in other words, we're trying to find the slope of a function using the limit process. So let's go ahead and look at the objective for today, in this video. State the formula for the derivative using the limit process. So there's a formula that you need to know. And then, of course, find the derivative using the limit process. So I have a video here that I created, and let me bring the PowerPoint so we can watch the little point. And what we want to do, we are trying to find the slope. We're trying to find the slope of at a point, and we have this point, and we're trying to find the slope of that point. So how do we find slope in calculus? Well, we need another point. So we're going to take this red point that you see appearing on the video, and we're going to try to find the slope between 2 points using Algebra 1 or College Algebra or Algebra 2, depending on where you learned it. So remember that formula is going to be y1 minus y2 over x1 minus x2. Now, let's go ahead and look at the x coordinates. The x coordinates are going to be very critical for us. As I move this point, what's happening to the distance between the black line and the red line? That distance right there is getting smaller, smaller, smaller. And then what happens when it's on top? It's 0. Now as I go to the right, that distance is getting bigger. So that distance between the red line and the black line, we're going to call it delta x. And delta x is going to be very, very important. Now what do I want? I want delta x to be 0. Why? Because when delta x is 0, that means that the red dot is on top of the black line. So right here, delta x is getting larger and larger and larger. Now it's getting smaller and smaller and smaller and smaller and smaller, and right there it becomes 0. So what we're going to do now is we're going to introduce a secant line and a tangent line. The slope of a curve at a point is the slope of the tangent. So if I was to zoom in, we're going to have this line right here that I'm going to extend. So that's called the tangent line. Now what I'm going to do is I'm going to connect the two dots, and the black dot and the red dot here, that's going to be called the secant line. So look at what's happening as the red dot goes on top of the black dot. The lines become one and the same. So as I go further away, now if you notice the slopes are different, but as I get closer and closer and closer and closer, the secant becomes the tangent. And that is what we're trying to do. We're trying to find the slope of the blue line, but what we're going to do is we're going to find the secant. Okay? So right here, I move the point, and as you can see it, when it's on top, they become one and the same. So you're saying, well, what do I need in order for me to figure this out? Well, what we have is we have 2 points. We have this one point there that's going to have a very simple coordinates. It's going to be x and f of x. F of x is a very fancy name of saying y, so it's x and y. And remember what we said. We said that it was very important that we travel some distance to find another point. Okay, now that point could be anything, but what I need to understand is that this part here we called it delta x. And what I want is I want to introduce delta x into my problem because I want delta x to become 0. I want the limit as delta x becomes 0. So if this guy is x and I travel some delta x, where am I going to be located? I'm going to be located at x plus delta x. Now my y coordinate there is going to be f of x plus delta x. So now I have 2 points. This is my second point, and this is my first point. This is the point that I want, and this is the point of the second point. And I'm trying to find, remember, I'm trying to get from this dot to that dot. So I'm gonna go this way. That means that delta x is getting what? Is going to 0. All right, so let me go ahead and go to the next slide. From Algebra 1, we know that the slope formula is going to be y equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. The first point that I chose was x, f of x. And remember how we traveled that delta x? Well, the second point is going to be this. So now using algebra 1, all right, remember my slope. My slope is going to be y sub 1. So I'm going to say f of x plus delta x minus f of x all over my x coordinates, which is going to be x plus delta x minus the other x coordinate. Well, this is really nice and fancy because I know that here I have an x and here I have a minus x. They're just going to cancel out to give me 0. So my slope is really going to be f of x plus delta x minus f of x all over delta x. Now, what we need to understand is I want delta x to become 0. So I am going to put the limit here as delta x approaches 0. By adding this, I'm going to make the secant become the tangent. So let's go ahead and look at an example using the limit process. All right, so let me write the formula down here. The limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. All right, now some students are going to have trouble. They're going to have trouble because they're going to look at this and they're going to say, sir, what is f of x plus delta x? Well, let me see. Let me go ahead and make some space here. And let's pretend I have f of x is going to be 5x minus 2. So I'm going to use 5x minus 2 here. And I ask students, what is f of 1? Well, they say f of 1 is going to be 5 times 1 minus 2, which is 3. And I said, all right, what's f of 5? And they can answer that question. They can say, that answer is going to be 5 times 5 minus 2, which is going to be 5 times 5 is 25 minus 2 is 23. Well, and then I ask them, what is f of p? Well, they do the exact same process. They're going to say, sir, the answer is 5p minus 2. What if I said f of delta x? Well, they're going to say 5 times delta x minus 2. Well, what if I said f of x plus delta x? And they're going to say, well, we're going to insert an x plus delta x into my function. So now we understand the concept of f of x plus delta x. So that means that I'm going to have the limit as delta x approaches 0 of 5 times x plus delta x minus 2 minus that minus is that minus right there, the original function. So I'm going to put the original function in brackets here. So I'm going to have 5x minus 2. And that is a common mistake students will make. They'll forget to put that brackets, and they'll forget to distribute this minus. So don't forget to do that. All over delta x. Now, I'm going to use some algebra. All right, I'm going to distribute here. So I'm going to distribute this 5, and I'm going to end up with 5x plus 5 delta x minus 2. And here I'm going to distribute this minus, so I'm going to get minus 5x plus 2 all over delta x. The limit as delta x approaches 0. Now, some of you are going to look at that and says, oh, hey, wait a minute, sir, I can see that the 5x here, the 5x and the 5x are going to reduce to 0. And I have this minus 2 and a plus 2, that's going to cancel each other out. So I'm left with 5 delta x all over delta x. And if I have the limit as delta x approaches 0 of 5 delta x over delta x, the delta x is canceled, and I'm left with the limit as delta x approaches 0 of 5. And that, the limit of a constant, is the constant. My answer is 5. And you say, okay, what does this mean? This means that my slope at any particular point is going to be 5. And guess what we have here? We have 5x minus 2. And 5x minus 2 is a linear function, and the slope of a linear function is the coefficient of the x, and the coefficient of the x is a 5, so my slope is 5. I just proved that the slope was 5 using calculus. All right? You're saying, wow, that was easy. I didn't have to do calculus for that. Well, the great part is that the limit process, you'll be able to look at something like this. You'll see x squared minus 2x. Now, this one, though, if I did a quadratic, my slope here is negative, my slope here is positive, and my slope here is 0. So this one's going to have different slopes at different locations. So let's write that formula down. The limit, that's one of the objectives, delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So I'm going to do this first part right here. So that part right here is telling me to substitute in x plus delta x. So let me include my limit here, the limit as delta x approaches 0. And I'm going to have x plus delta x squared minus 2 times x plus delta x. I have to insert it, substitute it wherever there's an x. I'm going to insert an x plus delta x minus, and I include my bracket here, the original function, x squared minus 2x all over delta x. Okay, now here I'm going to FOIL this, and when I FOIL that, I'm going to include my next step here, delta x approaches 0. I'm going to have x squared, multiply the 2 and double it, plus 2x delta x plus delta x squared minus, now I'm going to distribute here, and I'm going to have minus 2x minus 2 delta x. Here I'm going to distribute this minus x squared plus 2x all over delta x. Let's see if anything will cancel out. Well, I have an x squared right here, and I have a minus x squared here. That's going to cancel out. Then here I have a 2x, and here I have a minus 2x. So those are going to cancel out, and I'm left with this. Now, if I was to do the law of limits, and that's substitute a 0 there, if I plug in a 0 here, a 0 here, a 0 here, I would get 0 over 0. Oh, wait a minute, 0 over 0 in another video tells me that means that I can factor, rationalize, or get rid of the many denominators. And in this case, there is no fraction, there's no radical, so that means that I can factor. So what does this guy, and this guy have in common? They all have delta x in common. So I'm going to factor it out, and I'm going to have 2x plus delta x minus 2 all over delta x. And let's not forget that limit here in the front. So now we're about to get rid of the whole. The whole here, this guy and this guy are going to reduce to a 1. So I'm going to be left with the limit as delta x approaches 0 of 2x plus delta x minus 2. And now we do the law of limits, which means that we substitute a 0. We're going to take a 0, and we're going to insert the 0 right here for my delta x. So what happens when I plug it in? I'm going to get 2x minus 2. So this right here is going to be the slope. All right, the slope. Now later on, you're going to notice that the slope has different notation in calculus. It's going to be dy over dx. Some people will say, wait a minute, where did the dy dl? This is really delta y over delta x for those of you that are in physics. Or some of you might know the notation f prime of x. That means that it's going to be the derivative. Or if you're not using the function notation, you're going to say y prime is going to equal to 2x minus 2. All of these notations you're going to have to know. All right. So 2x plus 2. Now, why does my slope have a variable in it? And the reason is that here's my quadratic, and right here my slope here is 0, and right here my slope is positive, and right here my slope is negative. So if you notice, at different locations on my graph I have different type of slopes. That's why there's a variable found inside my answer. All right, and that concludes the video on the derivative using the limit process.